Transistors are commonly used in amplifier circuits to amplify sound. Here's how it works. In this setup, you'll find two resistors are connected to the transistor. These resistors provide bias voltage that keeps the transistor in an active or standby state when there's no input signal. The parallel resistor leaks just microamps when idle, just enough to keep the circuit ready, but not enough to fully turn it on. But once the input signal, say from a microphone or audio source arrives, the transistor is activated. It allows more current to flow from collector to emitter, thereby amplifying the audio signal. This is how small sound signals become loud enough to drive speakers. Here's another cool feature of transistors: voltage following. In this setup, the transistor behaves like a buffer that mirrors the input base voltage at the emitter output, with only a small voltage drop, like 0.7 volts. Why this voltage drop? Because the base emitter junction behaves like a diode, and it requires the emitter voltage to be lower than the base for current to flow. For example, if you apply, say, 5 volts to the base, the output at the emitter will be the base voltage minus 0.7 volts, around 4.3 volts. Even if the collector emitter voltage is 12 volts, the emitter output still locks at 4.3 volts. This resistor here, it's called a negative feedback resistor. It senses exactly 0.7 volts when the transistor conducts, stabilizing the circuit and improving performance.